Welcome to Algebra 2, Lesson 4-5, Solving Rational Equations. In this lesson, we'll be able to solve rational equations and identify extraneous solutions. What are extraneous solutions? That's part of the vocabulary. Rational equation, extraneous solution are the vocabulary that we will stress in this lesson. Let's start with critique and explain. Nikki and Tavan use different methods to solve the equation 1 over 2x plus 2 over 5 equals 9 over 10. Okay, explain the different strategies that Nikki and Tavan used and the advantages or disadvantages of each. So let's look at Nikki's strategy here. We have 1 over 2x plus 2 over 5 equals 9 over 10. We start with the same thing. Nikki did subtraction first to add the like terms of the constant and simplified by solving for x. Tavan, however, what did he do? He multiplied 10, which is the LCM of the denominator, and so he got rid of the fractions, and then he solved the equation without a fraction, and the solutions are the same. The solution is 1. So different methods, but still the same solution, right? So this is basically what you need to explain the different strategies they used. We can summarize and say that Nikki subtracted 2 over 5 to combine the constants and solved for x. Tavan, however, multiplied the LCM of the denominators to simplify the whole equation. Then solved for x. So part B, did Nikki use the correct method to solve the equation? Did Tavan? Yes. Both used correct methods. Their solutions are the same. Why might Tavan have chosen to multiply both sides of the equation by 10? Why would we do this? What is the benefit of doing this? Well, we could get rid of the fractions, right? By doing so, he gets rid of the fractions. Could he have used another number? Yeah, sure, but this is the LCM, which would be the most simple number, so that our numbers are as simple as possible. But of course, we could find another multiple of 2, 5, and 10, which is 20. He could use 20, but the numbers and coefficients are bigger. They get bigger. Okay. So in this lesson, we're going to ask this essential question. How can you solve rational equations and identify extraneous solutions? Let's look at example 1. Solve a rational equation. What is the solution to each rational equation? A rational equation is an equation that contains a rational expression. So if you see the equal sign like this, it is an equation. And if you see a rational expression like this one in the equation, it is a rational equation. So let's look at this rational equation in part A. 1 over x plus 4 is equal to 2. In order to solve this, you want to first figure out how to bring your variable into the numerator, because in order to solve for your variable, you need to have x in the numerator. You want x over 1 equals to a certain answer, right? So in order to do that, we're going to multiply both sides of the equation by the same denominator, just like how we would do to solve just equations, regular equations without a rational equation, but still like with rational numbers, right? So multiply the denominator, which is the expression x plus 4, on both sides so that we balance our equation. Our equation should still remain the same so that we're not changing the equation to get a solution for a different equation, right? We want a solution for this equation. So then you can cancel this out. So 1 is equal to 2x plus 8, 2 times 4, which is equal to 2x is equal to 1 minus 8. And so x is equal to negative 7 over 2. So the solution is negative 7 over 2. Okay, very easy. And then part B, you do the same thing. Multiply denominator, the expression in the denominator, and then cancel out what you can simplify, solve for x, and that's your solution. So let's look at try number 1, A and B. What's the solution for each equation in A and B? Solve the rational equations by yourself. Pause the video. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. 2 over x plus 5 is equal to 4. So you're going to multiply x plus 5 on both sides. And then you can cancel this out. So it's equal to 2 times 4x plus 20. Then if you solve for x, 2 minus 20 is negative 18. So x is equal to negative 18 over 4. Simplify. That's going to be negative 9 over 2. So negative 9 over 2. And then part B, do the same thing. Multiply the denominator on both sides. Cancel this out. 1 is equal to 2x minus 14. So 2x is equal to 1 plus 14, 15. X is equal to 15 over 2. Check your answers, see if you got it right. If you did, good job. Okay, let's look at example 2. Solve a work rate problem. Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she were working alone? So Cheyenne and Arthur together work for 6 hours, right? And we know she works twice as fast as Arthur. So this is double. She gets double work done in the same hour, right? So first of all, we're going to figure out expressions, how to write expressions to represent the situation. So we're going to let a variable x represent the number of hours Arthur needs to paint the wall himself. So x, he needs x amount of time. So Cheyenne works double as much, so that means she is going to work twice as much. So she's faster, so she needs half of the hour that he works to finish one work. So in other words, Arthur can paint one wall in X hours, or it's 1 over X of the whole wall in 1 hour. Does that make sense? So he can paint one wall, this is wall, in X hours. After X hours, he paints everything. But if we divide this by X, the amount of hours he worked, that means this is 1 over X of the entire wall, right? So 1 over X of a wall in 1 hour is the rate that he works. So Cheyenne is twice as fast, so she paints 2 over X of a wall in 1 hour. So that's a rate. And then together, using the distance equation, D is equal to RT. Well, in this case, D is the wall. Okay, so the wall represents the whole wall represents 1. So here you can just represent this as 1. So 1 is equal to together. The rate is this plus this, right? So because the rate is combined, right? So the rate, whoops, this is not the rate. 1 over X is Arthur's, plus 2 over X is Cheyenne's. And then T, they together work 6 hours to paint the entire thing, right? So here in this equation, using this equation, we can figure out X. So dividing 6 on both sides, we get this equation in step 2. 1 over X plus 2X is equal to 1 over 6. And then we can use, we can multiply X on both sides, or we can add 1 plus 2, right? 3 over X. 3 over X is equal to 1 over 6. And then we can multiply X on both sides. And then we can multiply 6 on both sides to get X is equal to 3 times 6, which is 18. So together, Arthur is working 18 hours. And then Cheyenne is working, 18 divided by 2. That's the rate, yeah. So it takes Arthur 18 hours to paint the wall alone. If he were to do it by himself, this is the rate that this is the time it's going to take for him to paint the whole wall by himself, right? And then for Cheyenne, she will probably paint it in 9 hours because she's twice as fast. Yeah. So using the first expressions, you can plug in X to figure it out. X is 18, so Arthur's going to need 18 hours. X is 18, so 18 divided by 2 is 9, so Cheyenne is going to need 9 hours. So use the distance equation, but it works for the project as well. D would also equal to one project or one thing that you need to be done or fill. Let's look at try number 2. It takes 12 hours to fill a pool with 2 pipes where the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? So pause the video, see if you can do this by yourself. Come back when you're ready for answers. Okay, are you ready? So it's very similar to example 2. It takes 2 hours to fill a pool with 2 pipes. The 2 pipes have different rates, right? So use the distance equation where D is really filling the pool. And so this represents the whole pool, which is going to be represented by 1. So filling the whole pool is 1, okay? And then rate, if filling the whole thing is 1, if distance is 1, right? Then the rate is going to be 1 divided by how many hours it took for each pipe, right? So water of one pipe flows 3 times as fast. So rate of the faster one is going to be 1, the whole pool divided by 3 times as fast as the other type. So if we say the slower one, rate of the slower one is 1 divided by x, right? X is the time that it takes for it to fill the whole thing. The faster one takes 3 times as fast. So 1 over x times 3. So that's going to be 3 over x. And these are the different rates for each one. So using the distance equation again, this is the project of the pool. This is the pool represented by 1. And then the rate together, 3x plus 1 over x is and times the time that it takes, so 12 hours, right, is going to be complete, right? So solve for x using this equation. It means we have 1 over 12 is equal to 3 plus 1, which is 4 over x. And so multiplying x on both sides and 12 on both sides, we get x is equal to 4 times 12, which is equal to 48. And this is in terms of hours. So the slower pipe, this is the rate. So the time is just x. Okay, so it's going to take 48 hours to for the slower pipe to fill the pool by itself. Okay, so let's continue with the next examples in the next video.